Hi, my name is Ben Lehman. I'm an undergraduate research assistant with the Nutrient Management Sphere program at Cornell, led by Karine Ketterings. This summer, I got the opportunity to work on a soil assessment project inspired by some observations from local dairy farmers. The farmers saw that in their cornfields, some sections yield highly almost every year, while other field sections seemed to be able to yield highly but were more variable from year to year. We decided to evaluate soil within yield zones to see if these in-field yield differences were related to soil characteristics. To do this, we created yield stability-based management zones for a local dairy farm. Yield stability zones use yield monitor data to categorize every 2 by 2 meter field section on the farm by both their historic yield above or below the farm average, as well as their year-to-year variability of corn yield, also above or below the farm average. This gives us 4 categories or quadrants. Quadrant 1 contains many consistently high-yielding field sections across the farm. Quadrant 2 contains high-yielding but more variable field sections. Quadrant 3 contains inconsistent and lower-yielding field sections. And Quadrant 4 contains consistently low-yielding field sections. To make our study more easily replicable, Jason Cho, a graduate student at Cornell, wrote an R-code notebook that used the yield stability zone maps to select sampling locations in the 3 selected fields at one dairy farm. For each field, we sampled in 15 clusters of 4 samples each for a total of 60 samples per field, or 180 samples overall. Here on the left, you can see the yield and variability of yield at each of our selected sampling locations. And on the right, the black circles represent our samples on the yield stability zone map for field A. And here you can see field B, which is very wide and about a 40-acre field. And here's field C. Greg Godwin, a research technician and GPS specialist, helped me to take soil samples in the field, and we then mailed subsamples to our partner for the project, Prolific Earth Sciences, Inc., which ran both their proprietary microbiometer app test as well as a microscopy test to estimate microbial biomass and fungal non-fungal ratios. Microbial biomass was highest in the high-yielding but more variable field sections and was slightly lower in the lower-yielding field sections. Just as a quick reminder, green, or zone 1, is consistently high-yielding. Blue, or zone 2, is still high-yielding but is less consistent. Zone 3 is inconsistent and lower-yielding. And red, or zone 4, is consistently low-yielding. And here are the combined results from our 3 fields. As you can see, on average across fields, zone 2 had the highest microbial biomass, consistent with the potential for these zone 2 areas to actually out-yield even the zone 1 areas, given that there's good growing conditions and that they're in one of their higher yielding years within that range of variability. Sanjay Gami, research associate at an NMSP, tested the soil samples for inorganic nitrogen, which somewhat correlated with microbial biomass, but did not correlate with our yield stability zones. Dr. Gami also taught me how to run active carbon soil tests, but active carbon did not seem to correlate with yield stability zones or microbial biomass for the 3 fields in this study. We're planning to run additional soil tests soon, including organic matter, Illinois soil nitrogen test, aggregate stability, soil compaction, as well as general soil fertility. So we're very thankful for our funding from Prolific Earth Sciences, Inc., as well as the Rawlings Research Scholarship and funding from the Cornell University Jumpstart Program. So please feel free to reach out with questions or comments, and thanks for attending this session.